Okay, this is the first Screencastify lesson that I've put on. This is not meant to be a substitute for class, but instead it's just for folks that maybe because of technical problems, they missed being able to go to class on a given day, or maybe you just want to have something to fall back on, but I still expect you to come to class when you can. So anyway, this is going to be much shorter than the lesson that's presented in class, but hopefully has most of the content just so that you didn't miss it. So anyway, today's topic in chemistry was about pressure. What is pressure? So pressure is force per unit area. The equation that you see there is P equals F over A. The units of pressure here in the United States, we use pounds per square inch. You may have seen PSI written on the outside of a car tire. Typically, automobile tires run between 30 and 35 pounds per square inch, where your bicycle tires, ironically, tend to run much higher pressure. Main reason that they run a lot higher pressure is you're exerting a force over a much smaller area. Think about little bitty racing bike tires where the wheel may be only about an inch wide. Those can run up to 90 psi at times. Other units of pressure are the Pascal. Pascal is 1 Newton per meter squared. That's the SI unit of pressure. And then another unit of pressure is called the atmosphere. Standard atmospheric pressure is 14.7 pounds per square inch, or 101,300 pascals, or what you'll see a lot of times on the weather is inches of mercury here. 29.93 inches of mercury is standard atmospheric pressure. At times, I've seen pressures as high as 32 inches of mercury, and in a hurricane, it'll get down to as low as 25 inches of mercury in the center of that. So that's extremely low pressure. Okay, well, let's talk about how you can find pressure. So the question here is, how much would it hurt if a 125-pound girl that you see standing to the right there stepped on your foot? Well, the answer depends on what she's wearing when she steps on your foot. So if she's wearing flip-flops that measure roughly 8 inches by 2 inches wide, how much pressure would she apply to your foot? So to figure that out, we can take here and go get the right button pressed here. So you say that pressure is what we're looking for. We don't know what it is, but in this case, it's going to be in pounds, and the abbreviation for pounds is LBS. You need to look up what that stands for. I used to know it once upon a time, but it's going to be pounds per square inch. And then the equation, pressure equals force divided by area. So in this case, the pressure is going to equal the 125 pounds. That's her weight, the force that she's going to apply to your foot, divided by the area over which that's being applied. Now, the area is going to be 8 inches. We're going to assume that it's going to be roughly rectangular in the bottom of a flip-flop, pretty close to being rectangular. So 8 inches, that shouldn't be squared actually, just 8 inches times 2 inches, which gives you 16 square inches. And if you put that into your calculator, 125 divided by 16 gives you 7 point something, gives you 7.81 pounds per square inch. So pounds per inch squared. And that's going to be the answer we're going to go with, which isn't a lot. Like we talked about, car tires, 32 psi, so that's less than a quarter of that. Now, contrast that with if she steps on your foot wearing these spiked heels, which a buddy of mine had this happen. His date for homecoming stepped on his foot while they were taking pictures. Well, she stepped on his big toe with the spike of her heel. And if you take that same, try and find the same pressure So force divided by area again is going to equal 125 pounds divided by 0.25 inches squared. That works out to 500 pounds per square inch, which is more than enough to break a bone. As it turned out, broke his big toe, and the rest of the night he was limping around. Okay, we look at an elephant here. So we got an 11,000 pound elephant. We want to know how much pressure an 11,000 pound elephant would exert on the ground if at least 2 of his feet are on the ground at all times. And each foot is roughly circular with a radius of 4. So I'm going to start there, since we know that pressure is equal to force divided by area. I'm interested, what's the area of those feet? So area is going to be equal to pi times r squared. So the area of each foot, trying to get used to using this stylus, pi times 4 inches squared. So that works out to be, let's see, works out to 50.3 square inches. Okay, and you got 2 feet, which means that the pressure for the elephant there is going to be equal to 11,000 pounds divided by, well, the 2 times 50.3. 2 times 50.3 is going to be 100.6 inches squared. So if we take 11,000 divided by 100.6, we get that the elephant is only going to be exerting a force on the ground of 109.3 pounds per square inch. And actually, elephants try, if you look, it's not just that they're lazy. If you look at the picture of this elephant, most elephants have 3 feet on the ground at each time. They move their feet one at a time. And that's because if they put too much weight on any one foot on that soft ground, it's going to sink right in there because of all that pressure. Okay, next we start talking about atmospheric pressure. In chemistry, this is a big deal for us because the atmospheric pressure affects so many things in the behavior of physical substances. Well, atmospheric pressure is caused by the weight of a column of air above you. Down here, I put that this isn't to scale. The atmosphere isn't nearly that tall, even though in most textbooks you'll see pictures like this. If it was to scale, the thickness of the Earth's atmosphere, I put down here, if the Earth was the size of a basketball, then the atmosphere would only be about as thick as a piece of tissue paper. But you scale that up and you got 50 miles or so of air stacked up above you. That's going to exert a pressure at sea level of 14.7 psi, or 101,325 pascals, or like I put here, something called a millibar, which a bar is actually a 100 psi, and then down here 29.92 inches of mercury. Well, what can you do with all that? Well, I got a video here that pulled up. I go back to where I can click on this. It'll pull up the video over here, and you see this train car. They sucked all the air out of it, and after they sucked enough air out of it, the difference in pressure between the inside of the rail car and the outside of the rail car was enough to crush this thing. And they did this with a big vacuum hose. Actually, it's what they use to clean out sewers and whatnot. So, all right, there's that. Last thing for you today, I would like for you to use atmospheric pressure to try and crush a can. Here's the demonstration that I did. Pretty simple demonstration. You're going to take a soda can. I'd prefer that it be a soda can, but any type of aluminum can will do. And you're going to add a little bit of water to it. See there, I added about 1/3 of a cup of water. And you put it on the burner of your stove and start heating it up. Now you should only have to heat it for someplace between 3 and 5 minutes. I switched to a bigger burner because I was getting impatient. Now you also need to make sure that you have a pan of cold water on standby, because what you're going to do once this starts boiling and has boiled for, I said, 2 to 5 minutes, you don't want to boil all the water away, but you want to heat it up enough so that the whole inside of the can is full of steam. It's okay if you have a little bit of water down here, but you want hot steam in this top part of the can. And then after you've heated it up for 3 to 5 minutes, you're going to take some tongs, just simple kitchen tongs that everybody should have lying around. Shut off the burner there, then I pick it up, quickly turn it over and drop it in, and you see what happens. It crushes that can in a hurry. Now, I would like for you to do this with if you have a younger sibling or a parent in the house that you could show, do this with them and show it to them so that they can see how this works. Be careful, the can is hot, and you don't want to get splashed by any water, hot water that may come out of there. So, your assignment then, if I get rid of this, here's the questions that you have to answer that I do a little follow-up on. Here's a question about the soda can and how much pressure is going to be exerted on the outside of the soda can. You do want to look up how to find the surface area of a cylinder. So that's good. And then down here, I show how you can earn some extra credit if you post a video of the reaction of the people that are working on it. But that's the lesson for today. If you have any questions, please email me and I'll get back to you as quickly as possible. Have a good day.